This is Unit 4D. It deals with ultrasound. So starting at the bottom, we have matter and its particles that we're interested in. Most obviously particles in the air, but also other particles. So it's atoms and molecules. Now they are in motion, a very particular kind of motion called vibration, which is a backwards and forwards or a repeated motion. So we've got two types. We've got longitudinal, where the motion, as we can see here with these blue circles, is in line with or parallel with the direction of travel. We've also got transverse wave, where the vibration is at 90 degrees or perpendicular to the direction of travel. And that gives us two examples of waves. So the red one here at the top we'll deal with first. As we can see, the individual points are moving up and down relative to this dotted line. The dotted line is called the undisturbed position, so there's no energy, they all just sit there. We've also got the amplitude, so this wave can be higher or lower or louder or brighter, and the wavelength speaks for itself. It's the length of one wave from peak to peak. Now with sound, it's slightly more complicated, but basically the same thing. We have these areas where they clump together as they crash into each other, and that's called a compression. So it's being compressed, it's denser, and that must necessarily be followed by an area of low pressure or a lower density called a rarefaction. So that's how the energy moves through the air, obviously encoding sound signals. So back to the idea of vibration here, you can have a lot of vibrations per second or very few, and we call that idea frequency, and the unit is hertz or Hz. Now here we can see the human auditory field, or in other words what humans can hear, and that goes from about 20 hertz to 20,000 hertz. Now animals such as cats and dogs can hear higher frequencies, and bats and dolphins even use sound to navigate and to catch their prey. Now moving on to uses of ultrasound, these are all medical uses. We have our concept of vibrating particles here again. The most obvious and well-known use is an antenatal scan. So here we can see the image being produced. It's effectively a speaker. It's a very high frequency speaker, but that's what it is. It's sending sound waves into the patient, and here we can see a little animation here. So the red half circles are the sound going in, and that will reflect off different surfaces. It will actually go into the unborn baby or anything else that we're interested in looking at, reflect back, and the computer can make sense of that. As those reflections come back, the computer knows the speed of sound, and it can time the reflections coming back, and it can produce an image from it. Now this is very much preferable to X-ray, for instance. First of all, it can see soft tissues, and it does so very safely. It really is just sound, so it does no harm at all to the patient. The second use is actually a more destructive use, but a helpfully destructive use. Here we have a bladder, and we have a stone here that's formed, calcified in the bladder. Very, very painful, difficult to remove with surgery. Surgery has risks, infection and so on. So if it's all possible, we send in just the right frequency of sound, and that slowly basically rattles the stone apart, and these still have to be passed, but much less painful, and it's at least possible to remove them from the body. And lastly, we have another application here. We can actually use sound to work out the speed of blood in various blood vessels throughout the body. So here we've got an artery and a vein, and we can see the different colors. Now the colors represent speed, and we can see the scale over here. Now how this works is, here we've got our speaker, our transducer, sending in the yellow sound waves. Now because the blood cells are moving towards the source, you can see here the blue waves are going to bounce off at a higher frequency than the yellow waves, the incoming waves. And again, our computer does our calculation, can look at the difference between those two frequencies, and we can work out the speed of the blood and whether it's traveling towards us or away from us. So there we have it, 3 very powerful uses of ultrasound.